Now let's look at our lab frequency modulation. In our DATEX board, we have VCO component, that's the voltage controlled oscillator. And in our first part in the lab, we're going to give the input signal of VCO as a digital signal. What's this? Rectangular wave. You observe the input of the oscillator and output of the oscillator. In the second part, we're going to input a sinusoidal signal, and now we're going to modulate the sinusoidal signal using the VCO. Unfortunately, we do not know details about this VCO component in the DATEX board. If we modulate this sinusoidal signal, we do not know the modulation index. In this lab, you're going to find out what is the modulation index in the circuit board you use. And different circuit board may have different beta values. We know the angle modulated signal, where the message is cosine signal. The frequency component in the modulated signal contains frequencies Fc and Fc plus Fm and Fc minus Fm. The magnitude is AC multiplied by the J and beta. In this lab, we're going to measure the magnitude of the frequency components in the modulated signal. Here we have this. The magnitude of this is supposed to be AC J of 0 beta. For frequency Fc plus Fm, the magnitude is supposed to be AC J1 beta. And for Fc minus Fm, the magnitude is supposed to be AC J minus beta. So if we know the magnitude here, using these values, we can roughly figure out the value of beta. And of course, you're going to choose the best value of beta because you're going to have several of measurements regarding beta. Then you're going to make the best. Using the Bessel function table, you're going to make the best judgment for the value of beta, given all of this magnitude here. And pay attention that in the lab, the spectrum gave out your power. For cosine signal, that's the magnitude squared divided by 2. So when you see in the lab, you see the specs in a certain frequency, this magnitude is AC squared divided by 2. So to change it to magnitude, do a little calculation there. So that's this lab